In section 3.4, we're going to continue our discussion on solving equations. In particular, we're going to focus on solving equations that have variables on both sides. Okay, so same concepts, just a little bit more complicated. So step one is still going to be to simplify both sides. Combine your like terms and or use the distributive property to kind of get everything so it's nice and neat and reduced down. Step two, now we're going to add or subtract a smaller variable to the other side to combine like terms. What that's going to do is it's going to keep our coefficient of our variable positive, which will make things easier because we don't have to worry about a negative sign goofing us up. The third step, add or subtract the constant that is on the same side as the variable. And the fourth step would be to multiply or divide by the coefficient of x. Okay, so I have a few examples here that we'll take a look at. So the first one, right, simplify both sides. Already done. I can't do anything. Step two, subtract the smaller variable from both sides. So on the left-hand side, I have 15 equals 9a minus 4a is 5a minus 5. Add the constant now. Now it's a simple two-step equation that we worked on before. Okay, so we have 20 equals 5a. Divide both sides by the coefficient of a, which is 5. So a equals 4. Again, if I plug this 4 back into the original, it should work out. Okay, it should check out. So again, take the time to do that. I'm going to be very critical, especially on assessments that you're showing me the check, and you should be critical on your own accord there to be diligent in checking your work. Okay. All right. The second example. Now I have a little bit of work to do because I'm going to take this 6 and I'm going to distribute it. Okay, so I take the 6 to both sides, or to both things inside. So I have 4t minus 12 equals 6t plus 18. Okay, now we're right back to step one. Subtract the smaller variable from both sides. So I have negative 12 equals, because those cancel, negative 12 equals 2t plus 18. Subtract the constant from both sides. Again, I'm trying to get t by itself, so I get negative 30 equals 2t. Divide both sides by 2. That tells me that t equals negative 15. And again, create good habits. Take your time, plug that thing back in, make sure that that is the correct answer, and we should be just fine. Okay. Some more examples here, so I'm going to fly through these. I'm not going to say quickly, but at a little bit faster pace. So this is pretty basic, right? Subtract your 3b from both sides. So we get 7 equals 5b plus 2. Subtract the constant, so I get 5 equals 5b. Divide both sides by 5. That tells me that b is equal to 1. And finally, example D here, or part D of the first set of examples. I'm going to go ahead and distribute here. So I have 6d minus 6 equals, distribute the 3/4 to both guys inside. So I have 3/4 times 4d over 1 plus 8 times 3 over 4. Okay, so I get 6d. My task now is to just simplify both sides. This 4 and that 4 cancel. So I get 3d plus, this is 8 over 1. So this thing right here is actually going to be 24 over 4, which is 6. And now we're right back to square one. Subtract the smaller variable. So I get 3d minus 6 equals 6. Add your 6 to both sides. You get 3d is 12. And then divide by 3 on both sides to get d equals 4. Okay. Again, I know I'm going through this video quickly, mainly because I feel like you have a pretty good handle on this, and you can rewatch as many times as you feel you need to. Okay, something new from this section. Okay, only one value for x will be a solution to the equation 2x equals 6. Okay, there are infinitely many solutions. If you work out and your x's end up canceling, you'll notice here I would subtract 3x from both sides. So this guy cancels and this cancels, so you get negative 2 equals negative 2. If that happens, and that's a true statement, that's what's called an identity. Okay? That's an identity. And so the answer here, the solution, would be all real numbers. You could plug in anything for x, and it's going to work. Now, if you look at the next little section, if I subtract 3x from both sides here, right, they cancel, I get 2 equals 10. I think we all agree that that is not true. And if it's not true, okay, if it's a false statement, then that means that the answer is very simply no solution. Okay, and so the next set of examples here, we'll take a look at things like this. Okay, so again, distribute. We solve it the same way we would, like we were doing before. So I get 4x plus 5 equals 4x plus 20. Subtract your 4x from both sides. Now what happens here is they cancel. I get 5 equals 20. That is not true. Therefore, there is no solution here. Okay? No solution to that particular equation because 5 does not equal 20. If I take a look here at part B, again, distribute and simplify. So 6x minus 3 equals 6x minus 3. Okay? Subtract your 6x from both sides. They cancel. You get negative 3 equals negative 3. Whoops. That is a true statement. Therefore, all real numbers is your solution. Okay? Or infinitely many solutions would be the equivalent. Again, just a couple more examples here. At this point, if you're feeling confident, I would just pause the video and go through and work through it on your own if you'd like. So I'm going to distribute the 1/2. So I get 2t minus 3 equals 27. Add 3, add 3, so 2t is 30. Now I get rid of the multiplying, so I divide both sides by 2, and t equals 15. And then finally, the last example we'll look at in this particular video, and again, if you want to slow it down and replay it, do that. If I'm going too fast and you're not understanding, bring questions to class, and we'll go from there. So I get 10m minus 4. I distribute the negative 2. I get negative 4 plus 10m. So I subtract my variables from both sides. So what happens here is they cancel and they cancel. So I have negative 4 equals negative 4. That is true. Therefore, all real numbers is your solution. Okay, so I know I went through the video rather quickly, but again, if there are issues, bring them up. If you're not sure, you want to rewatch the video, go ahead and take the time to do that. And as always, we'll take questions in class.